Today we'll be looking at what similar triangles are. As a quick review, we got to look at what the definition of similar means. Similar, of course, what we learned about yesterday means two conditions have to be met. First, all the angles must be congruent, and second, the sides must be proportional. Finally, we also learned the symbol for similar is the little squiggly line. So for two polygons to be similar, these two conditions must always be met. So, with triangles, of course, as there was with congruence, there's ways to find shortcuts with similarity, and we're going to be looking at three of those. The first one is what we call angle-angle similarity, and this is if the measures of the corresponding angles of two triangles are congruent, then the triangles are similar. So if we can find two angles, like 65 and 65, and let's solve for our missing angle here is going to be 55, so 55 and 55. If we can find just two angles that are congruent, then we know the triangles are similar. Once again, we don't know they're congruent, but we do know they're similar. If they're similar, that means the sides, of course, are proportional. So I could say, because these two triangles are similar, that BA over RQ equals AC over QS. Because once again, they're similar, so the sides would be proportional. And if I need to write a similarity statement, it would be triangle BAC is similar to triangle RQS. And that would be, of course, by AA similarity. The second one we're going to look at is side-side-side similarity. Once again, this is not congruence, but similarity. If the measures of the corresponding sides of two triangles are proportional, where they're proportional, not congruent, then the triangles are similar. So we have to check all three sides to see if they're proportional. So let's see here. We want to line up the smallest side with smallest side, middle side with middle side, biggest side with biggest side, because the triangles could be rotated or reflected. So the smallest side here is 12 over 8 is the smallest there. We have to check to see if it's equal to 15 over 10 is the middle side. And we have to check to see if that's equal to 18 over 12. Well, 12 over 8 becomes 4 over 3 when you reduce it. Nope, I'm sorry, that's not true. It becomes 3 over 2. 15 over 10 becomes 3 over 2. And 18 over 12 becomes 3 over 2. So these sides are all proportional. So I can say that triangle BAC is similar to triangle RQS by SSS similarity, because the sides are all proportional. So if I know that they're similar, what could I say about angle B and angle R? Well, I could say that they're congruent, because if the triangles are similar, then the angles are congruent. Okay, here we're going to look at our third postulate now, which is the SAS, side angle side similarity postulate. And this states if the measures of two sides of a triangle are proportional, so once again, proportional, not congruent, to the measure of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So we have to check the sides and the angles to see if they're proportional. Well, just looking at this example, it doesn't seem like it's going to work. And why do you think it's not going to work if you look at it? Well, is the angle included between the sides? No, so this would not be a good example of SAS. However, if I take this 50 degrees and I put it here instead, we could actually check it because we have a side angle on a side. So let's check the sides to see if they're proportional. 15 over 10 has to equal 12 over 8. Well, 15 over 10 becomes 3 over 2. 12 over 8 becomes 3 over 2. So that checks out. So we have two sides, and the included angle is congruent. So I can say that triangle BAC is similar to triangle RQS by SAS similarity. So those are the three postulates we're going to be looking at and practicing with today. So take a second to determine if these two triangles are similar. Okay, so ask yourself first, Which of the three could it be? Well, we only have one angle, so it can't be AA. And we only have two sides, so it can't be SSS. So it could be maybe SAS. So we have to check the angles. They are congruent, so the angle part works. Now let's check the sides. So 10 over 6, does that equal 15 over 9? Let's see, 10 over 6, 2 goes into that, so it's 5 over 3. 15 over 9, 3 goes into that, so it's also 5 over 3. So this would be similar. Triangle MNO is similar to triangle KLJ by SAS similarity. What about these two triangles? Which one could it be? Could it be AA? Well, no, there's only one angle in this one and none here. Could it be SAS? Well, I don't have any angles here, so no. So the only one it could be is SSS. So let's check that. 10 over 5. Remember, we're lining up smallest with smallest. Middle with middle, 18 over 9. And large with large, 20 over 10. That becomes 2, 2 and 2, so these are congruent. Triangle MNO, sorry, they're not congruent, they're similar. Is similar to triangle KLJ by SSS similarity. What do you think about this one? There are no numbers here. So could this top triangle be congruent to this big triangle? Well, do you have any reflexive angles? Sure you do, right here. So this side being congruent to this side, and this side to this side, if you plug in numbers, look at, let's say this is 2 and this is 2, this is 3 and this is 3. Would 2 over 3 be equal to 4 over 6? Yes, it would. So anytime you have a picture that looks similar to this, you can tell that these two triangles are indeed similar by SAS similarity because of the reflexive angle. How about here? Are these two similar? Well, could it be AA? No, only one angle. Could it be SSS? No, missing a side. And could it be SAS? Well, no, because the angle is not included. So do we have enough information? No. All right, this one has two triangles that are kind of flipped together, pushed together here. So we can check to see similarity here as well. We know that this angle would be congruent, and we don't know anything else about other angles, so it can't be AA, can't be SSS, so let's check SAS. Let's see, 3 over 18, does that equal 9 over 9? Well, obviously no, that one doesn't work. But let's take this triangle, and let's flip it and see if we can do anything with it. So if we flip it to where it goes up, the 3 would come here, and the 9 would go here. So let's check. 3 over 9. Does that equal 9 over 18? No, that doesn't work either. So we do not have enough information to tell if this triangle, these two triangles are similar. So make sure that you check different ways that you can move the triangle for similarity. All right, so here's where it gets a little bit difficult. We'll be solving for x and y. And so let's do this one together. And I'm going to warn you to be careful of something called side splitting here, which sometimes works and sometimes doesn't. So I'm just going to teach it as if it doesn't work because it's easier just to do it one way every time, in my opinion. So here we have a top triangle and then a bottom big triangle. Sorry, the whole thing is a big triangle. So 8 over, let's see, 8's this part of the side, and 12 would be the whole side. So 8 over 12. Don't put 4 here because the whole side of the triangle is 12. This part's 4, but the whole triangle is 12. So 8 over 12 equals, this side corresponds to the 8. It's in the same triangle, I should say. X over 15. We can solve that. Cross multiply. 120 equals 12x, so x equals 10. All right, that wasn't too bad. Now let's do y. So we could do here, let's see here, we could also start with 8 over 12 equals, because 8 over the whole side 12, 10 over, and what's this whole side going to be here? Well, it's going to be 10 plus y. So Cross multiply. 8 times 10 is 80. 8 times y is 8y equals 120. Subtract the 80. 8y equals 40. So y equals 5. So this little piece here is 5. All right, I want you to pause the video right now and try this one out on your own. See what you can do with it. All right, let's see how you do with it. First off, we know these triangles are similar. I'm sorry I didn't address in the last one, but we know they're similar because you have parallel lines, so you know if this angle is congruent to this angle, and this angle is reflexive in both. So you can say that these two triangles are similar by AA. All right, so let's check to see how we solve for x and y here. So x is the whole side, y is the bottom. So let's start with over 15 over 21. Because remember, we have to do the whole side, not just a piece of it, equals 12 over the whole side here is x. Well, cross multiply, so 15x equals, let's see, 210, 252. Divide by 15. So x will equal, oh goodness, 3 goes into 252 84 times. And then into 15 5 times. So 84 over 15, or you could of course write that as, let's see there, 16.8. So either way works there for all of x. Now let's check y. So we can still start with our 15 over 21, and we can set that equal to 10 over y. So this problem's not too complicated in that sense. So 15y equals 210. We divide by 15, and that makes y equal 14. Yeah, 14 right there. So hopefully you got that right and that problem made sense. Just once again, be careful that you don't do 15 over 6. So that's 15 over the whole side being 21. All right, let's look at two more here, I believe, and then we'll be done. And you'll get time to work on your homework. So we have 5 over 15. That's an easy way to start this problem because the whole side's 15 equals y over 9. So y is not too bad. 45 equals 15y. Y equals 3. Once again, we can stay with the 5 over 15. That's not a problem. Equals, well, we don't know this little piece here, but we do know the whole thing's 22, and this piece is x. So we could actually call this piece right here 22 minus x. So if we subtract x, we get what's up here over the whole thing, which is 22. So cross multiply that. You get 110 equals 330 minus 15x. Subtract 330, so negative 220 equals negative 15x. And divide by negative 15. And I believe that's going to give you a, let's see, 14 and 2/3 as your answer for x right there. All right, one more. I want you to pause the video and try this one on your own. All right, so we have x and y here. We have parallel lines, so we know that they're cut by a transversal, so alternate interior angles are congruent, and vertical angles are congruent. So we know these triangles are similar by AA, so I could actually solve for the missing sides. So 10 over 15, those are corresponding, equals 8 over y, that's one setup, and then 10 over 15 equals x over 12. So just solve both of those and you're done. 10y equals 120, so y equals 10. Sorry, not 10, 12. And then cross multiply here. 120 equals 15x. Divide, of course, so you get x equals 8. So finally, here's your homework assignment. Go ahead and get started on it and do your best with it. Good luck.